Have you ever watched a brand new app just blow up overnight and wondered how in the world is it not crashing? Well, I can tell you it's not magic. It's a journey of really smart engineering. So today, let's pull back the curtain and break down exactly how you go from a single server to a global powerhouse that can handle millions of users.
All right, so here's our roadmap for this explainer. We're going to start at the very beginning and level up, step by step. We'll see how to survive that first huge traffic spike, how to make our data safe and sound, and finally, how to get that lightning-fast performance for users all across the globe.
You've got to remember, every massive system we use today started out small. This whole process isn't about one giant, complicated leap. It's really a series of smart, deliberate moves. So let's get started with step one. Okay, this is ground zero. This is where pretty much every new application or website starts its life. The simplest setup you can possibly imagine. So, in the beginning, it's all about this one lonely server. A user wants to visit your site, their browser asks something called the DNS, you can think of it like the internet's phone book, for your server's IP address. Once it has that, the request goes straight to your machine. And that one server does literally everything. It runs the web app, it manages the database, it figures out the response, and it sends it back. It's a one-box show. Simple and clean. But, as you can probably guess, this doesn't last for long. And that simple setup works great. For a while. But then people actually start using your app. As more and more users show up, that one server starts to sweat. Things get slow. But even worse, you've created a single point of failure. If that one server goes down, your entire application is just gone. Which brings us to our first major hurdle. What do you do when that one server just can't keep up? We've all been on the other side of this, right? Hitting refresh on a website that's just crawling along, or worse, won't load at all. That's the exact problem we have to solve now. So we get to a fork in the road. We have two basic paths. The first is vertical scaling, or scaling up. This is like buying a bigger, more powerful server. More CPU, more RAM. It's easy, but you're going to hit a ceiling eventually, and it doesn't solve our single point of failure problem. The real pro move, the one that lets you grow almost infinitely, is horizontal scaling. We're scaling out. Instead of a bigger server, we just add more servers. This is how the giants of the internet are built.
So we're choosing to scale out. And the very first thing we do is start to separate the concerns. We take the database and move it onto its very own dedicated server. And just like that, we've created two layers or tiers. The web tier is for handling all the user requests, and the data tier is just for the data. The beauty of this, now we can scale each one of these tiers completely independently.
Okay, this next piece is an absolute game changer. We add something called a load balancer. It sits in front of our web servers and it acts like a really smart traffic cop, directing incoming requests to the different servers. This solves two massive problems in one shot. First, if we need to handle more traffic, we just add another server. Easy. Second, if one of our web servers fails, the load balancer sees that and just stops sending traffic to it. Just like that, our single point of failure for the web tier is gone.
So our web tier is looking pretty solid now. But you see what we did, right? We've basically just moved the bottleneck. Now our single database server is the weakest link. So it's time to focus on protecting our most valuable asset, all that user data.
And this is the question that keeps engineers up at night. Because if that one database machine fails, it's not just that the site goes down. We could actually lose data. That's a scenario we absolutely have to prevent.
The solution is a strategy called replication. We set up one database as the master. Its job is to handle all the writes, anytime data is created or changed, like a user posting a new photo. Then we create several slave copies whose only job is to handle the reads, like when someone views that photo. And here's the key. Most applications have way more reads than writes, so by spreading the read requests across multiple servers, we get a huge boost in performance. So, to quickly sum up the wins here. First, much better performance, because all those read requests are happening in parallel. Second, reliability. Our data now lives in multiple places, so we're protected if one server is lost. And third, high availability. If one of our databases goes down, one of the others can step in and take over. The site stays online. Okay, our system is getting pretty robust. It's reliable, it can handle a lot more users, but it's not done yet. Now we want it to be fast. I'm talking lightning fast. It's time to tackle the next challenge, making the whole experience feel instantaneous for the user.
And our first tool in the fight for speed is the cache. The best way to think about a cache is as a super fast, short-term memory for your application. Its only job is to hold on to data that gets requested all the time, so we don't have to bother our slower, busier database for it every single time.
So here's how it works in practice. When a request comes in, say, for a user's profile page, the web server checks the cache first. If the data is there, we call that a cache hit. It's sent back to the user instantly. If it's not there, a cache miss, no problem. The server just goes and gets the data from the database like normal. But before sending it back, it saves a copy in the cache for the next time someone asks for it. It's a massive performance win.
All right, next up for speed is something called a content delivery network, or CDN. Now, the cache we just talked about is for our dynamic data, the stuff that changes. A CDN is for all the static stuff, the things that don't change very often, like images, videos, JavaScript files, and so on.
A CDN is basically how we solve the problem of physical distance. It's a whole network of servers spread out all over the world. They all store copies of our static files. So when a user in, say, Japan requests an image from our site, they don't have to wait for it to travel all the way from our main server in the US. Instead, it gets delivered from a CDN server that's physically located much closer to them, maybe even in Tokyo. Less distance equals way faster load times. This is what makes websites feel snappy no matter where you are in the world.
So let's just pause and take a look at our system now. We've got the load balancer, our fleet of web servers, our replicated databases, and now we've added two powerful new layers of speed on top. We've got the cache for our dynamic data and the CDN for our static files. Our app is feeling way faster for our users.
We are getting so close to the finish line. To truly prepare our system for millions upon millions of users and achieve that top-tier, rock-solid reliability, we just need to make a couple of final, really crucial architectural shifts.
And this next concept is absolutely key. We need to talk about stateful versus stateless architecture. In a stateful design, your web servers remember things about a user's session, like who they are, what's in their shopping cart. The problem is that user is now stuck to that specific server. But in a stateless world, we move all that session information out of the web servers and into a shared storage layer. Now, any server can handle a request from any user because they all have access to the same session data.
And this is what that looks like in practice. A user's request comes in through the load balancer and hits any of our web servers. That server just quickly grabs the user session info from that shared storage, processes the request, and sends the response. This incredible flexibility is what makes it so easy to scale. It's what allows for cool things like auto-scaling, where the system can automatically add or remove servers based on how much traffic we're getting.
And here we are, the final form, the peak of the mountain. We're now running our entire application stack in multiple geographically separate data centers. A clever service called GeoDNS looks at where a user is coming from and automatically sends them to the data center that's closest to them, which is great for speed. But the real magic is for reliability. If an entire data center were to go offline because of, say, a power outage, the traffic just gets automatically rerouted to the next closest healthy one. This is the pinnacle of performance and resilience.
So there you have it. We went from a single, humble server to a resilient, globe-spanning system. Along the way, we added a load balancer, we replicated our databases, we introduced caching and a CDN, and we moved to a stateless architecture across multiple data centers. We've built a system that's truly ready for millions of users. So, the only real question left is, now that you've seen how it's done, what are you going to build?